Hello, this is Anurag here. Today, for the Coursera Machine Learning Foundation for Product Managers, we are trying to perform a project that is under the project topic as Machine Learning Module for Predicting the Power Plant Electric Energy Output. We are going to follow four steps, and the first step is to define the problem and what is the output metric selection that we are going to use. So the problem definition is predicting the electrical energy output of a power plant based on electrical readings, and we are dealing with the regression task here. And the output metric selection, an appropriate output metric for the regression task could be the mean squared error. So that means the lower MS indicates the better performance. And how we can do it? We can do it by average square difference between the predicted and the actual values. Coming to step two, so this is a feature selection and algorithm identification. We have four features, that is temperature, ambient pressure, relative humidity, and exhaust vacuum. And the regression algorithms that we have selected is the linear regression, random forest regression, and gradient boosting. The step three is data splitting. We will split the data into training set and the test set. A common approach is to use 70-30 split. Step four would be the model comparison and selection. Under this step, we will try to compare the three models that we have selected, that is linear regression, random forest regression, gradient boosting regression, and each model will be trained and evaluated multiple times to determine the average MSC. So the model with the lowest average MSC will be selected as a final model. So today what we have over here is collab.research.google.com, wherein we are trying to import the NumPy and the pandas so that it will be easy to calculate and define this. On the flip side, we have ccpp underscore data underscore new.csv. That is the data that was provided by the Coursera. And as soon as we imported the data into the commandlet, it gave that all the values are perfectly fine. There is no discrepancy identified under the data. That's what we did, and we also ran df.describe to understand how the value look like. So we have different values and all seems to be great. So what we did again, what we have is over here is from sklearn.preprocessing, we imported the min max scalar, and then we went into splitting the data into training and the test data. Then we imported the train and test split module into the program, and we used the train shape and the test shape. Post that, once the data is defined as a training data and the test data, we went ahead and we imported the linear regression module into the program, and we are running this linear regression module, and we calculated the mean squared error over here that turns out to be 21.023. Similar way, we ran the second module, that is the random forest regression. We imported the module random forest regression, and we are running it. During that, once we ran it, the value came out to be the mean squared error value came out to be 34.8124, which is higher than the linear regression, which means linear regression is better than the random forest regression in this scenario. But we do have another set of module that we would like to test and evaluate, and we need to identify out of these three which one is better. So for that, we are going to import the gradient boosting regression module into the program, and that's what we are trying to do. And we trying to fit the train data into the module, and then we are trying to run across the mean squared error, calculating difference between the predicted and the original data, and then we ran the mean squared error, and the value came out to be 15.574, which means the the gradient boosting regression is much better than the random forest regression and the linear regression. Thank you.